Leetcode problem 802, find eventual safe states. Let's first try to understand the problem. Maybe the drawing is not so clear, but I will explain it. Yeah, let me make it bigger, maybe like this. Yeah. So there is a directed graph of n naught. So the naught is going to be starting from 0 to n minus 1. So this is okay. Yeah, so this is easier for us to construct the graph because yeah, it is just starting from 0 to n minus 1. The graph is represented by a 0 index 2D array. And we need to understand what is the representation of this kind of 2D array. So this basically means, yeah, so 2D array. So for inside of the graph, there's going to be an array. So graph I is an integer array of nodes adjacent to node I. So this means inside of the array, the index is 0. So this means the index is 0. There will be a node 0 connected with node 1. So this is node 1 connected with node 1, and there's a node 0 connected with node 2 as well. So this is basically the meaning of this area. Graph I is an integer array of nodes adjacent to node I. So meaning there is an edge from node I, this is 0, node 0, to each node inside the graph I. So inside the graph I, there's node 1 and 2. So this is the meaning. So a node is a terminal node. So this is a terminal node. So for 5, this is also a terminal node. Yeah. If there are no outgoing edges, so for 5, there's no outgoing edges, and 6, no outgoing edges. Yeah. A node is a safe node if every possible path starting from that node leads to a terminal node. For example, for node 4, so all the outgoing edges coming to a terminal node. So this is also a safe node for node 4. And also for node 2, as you can see for node 2, for all the outgoing edges, it goes to a terminal node 5, because 5 is a terminal node. So 2 is also a safe node. So our final result is going to be 2, 4, 5, and 6. Why 0, 1, 3 not possible? Because for either of them, for 0, 1, 3, it's going to be a circle. It means for the outgoing edges, definitely it cannot go, there's not only one edge going to a terminal node. For example, for node 3, it goes to node 0. For node 0, it goes to node 1. And for node 1, it goes to node 3. Even 1 goes to 2, but there's still another node goes to 3. This means it is not a safe node. Yeah, if you basically understand about this, now you're going to try to find a solution to solve the problem. Basically, this is a kind of, yeah, let's just try to make a drawing first. Maybe it's not clear. So our drawing is like this. We have a circle, and inside of the circle, we have some node. Definitely, this node cannot be the result, but we're going to have some other node. For example, it is connected to the circle, and there's another node here. There's another node here, and this node here. Yeah. So what we are going to do, we have this kind of a graph, and what is our result? Our result is coming from this area. Yeah. So this is gonna be our result, because definitely the circle will not be our result. Yeah, according to the definition. So what kind of data structure can help us to solve the problem if we don't want to include the circle, we only want to include the tree structures like the right side? Of course, the topological sort would help us solve the problem. So the first step for the topological sort is that we're going to first find the node, which is the children. Yeah. So for this node, it is a children, and the integer for this node is 0, and the integer for this node is 0, and we're going to check those two nodes first, and then we're going to get this node. Yeah. If we get this node, we're going to get this node, the integer is going to become 0, and then we're going to get the final node, this one. Maybe this is 0, 1, 2, 3. So we're going to get the result like 0, 2, 0, 2, 1, and 3. But after that, we're going to sort it, because we need to return the array in ascending order according to the return requirement of the problem. Yeah. So if we understand about here, basically we can solve the problem. But for building of the graph, for us, it is the building of the. But for building of the graph, it is, for example, it is a 0 to 1, it means we are building a circle, and this may maybe go out, go out, go out. It is like that, yeah. But for the graph, we should know that it should be not goes to this node. So this node should go backward. If all the nodes need to go backward, it means we need to turn all the directions by using the topological sort. Yeah. So this means the directions would be like this, this, and this until it goes to the circle, and then it cannot go inside because by definition of topological sort we cannot go inside according to the algorithm. But definitely we can check all those nodes. Yeah. Because if you did not turn the direction, how can you find this node? You cannot find. Only if you turn the direction of the node, you can use the topological sort and to find all the possible nodes. If you didn't turn it, so how can you find it? Maybe you're gonna check inside the circle, but it's gonna be difficult. So the better way is if we were to use the topological sort, we're gonna turn all the as directions, and then we're gonna use it to solve the problem. And we just need to put all those nodes inside the array and return the result. Yeah. Now let's try to solve the problem. So we're gonna prepare an adjacency list as graph and integrate as an array. So it's gonna be default dict and with the list, and for the integrate it's going to be 0 times the number of the node. It is the length of the graph. So now we are going to check the graph. Actually inside it is an array. So for array inside the graph, yeah. So I need to know the index, so I'm going to use enumerate. So for I array in enumerate the graph, I'm gonna check each node inside of the array. So for each node inside of the array, first of all, I'm gonna build the graph. Yeah, as I need to turn the direction. So for example, for the first one, it's gonna be 0 to 1. Now it's gonna become 1 to 0. So this means G node needed to append with I because I needed to turn the direction. And similarly for the integrate. So for the integrate, it's going to be integrate with I should plus equal to 1 because I needed to turn the direction. So the integrate need also to change. We need also to change the integrate as well. So it's going to be integrate with I. It means the integrate 0 gonna plus 1. Yeah. So this means definitely 0 to 1. It becomes 1 to 0. So integrate I gonna plus equal to 1. It means we turn the direction. Now we're going to prepare a queue and result. So queue is going to be the queue as always for the topological sort. So for I we enumerate the integrate. So if this v equal to 0, so we're going to put all the nodes inside, and the result is going to be an empty array. Now we can check the queue, and we're going to pop it out. So it's going to be q dot pop left, and we can put this node inside the result array. Yeah, and then we can check the neighbors. So for neighbor in G node, so we're going to check the integrate. So integrate for this neighbor gonna minus equal to 1, and if this integrate with this neighbor equal to 0, definitely we're going to put it inside of the queue. Yeah, so we're going to put this neighbor inside of the queue. Finally, we're going to return this result array because this is what we are going to check. Yeah, but this is not yet finished. We need to sort the array according to the description. So we're going to sort this result. Now, let me submit it to check. As you can see, it works. Now, let me submit it to check all testing cases. As you can see, it passed. I think the speed is okay. Basically, if we are using the topological sort, it's going to be O. The time complexity is going to be O E plus V. E is going to be the number of edges, and this is the number of vertices. And let's just check the number of edges. So for graph I's length should be equal to n, and the number of edges in graph will be in the range. Yeah, because if it is set from here, we don't know about it. But if it is set about here, it means the total number of edges is 4 times 10 to the power of 4, and the number of vertices is 10 to the power of 4. So it means the time complexity basically is going to be 10 to the power of 4. That is why it is so fast. Thank you for watching. See you next time.